Bismillahirrahmanirrahim. This video is about linear transformer. This is from chapter 13 of Mr. Alexander and Sadiku's book. And here primarily we'll be solving example 13.4 and practice problem 13.4. So what is a linear transformer? A transformer is called linear if the coils are wound on magnetically linear material. And what does this mean? Such materials include air, plastic, bakelite, and wood. That means non-ferrous material. A transformer wound on a plastic body or on a bakelite or wood or even in the air, that means on paper or anything else. So that those transformers will be called linear transformers, and here we'll be discussing those transformers. Basic circuit, we'll use this circuit. And here R1 and R2 are actually the resistances in the coil, so they have been taken out and written here. Okay, so the first step should be that we convert this into phasor form. So L1 will be written as j omega L1, L2 j omega L2, and M j omega M. And then we know that there is a voltage induced from primary to secondary and secondary to primary. And we have already discussed in previous lecture that we show it by diamond sign. And the sign of diamond is actually depending on the current. If the current is touching the dotted terminal, that is in the top terminal, then positive will be at the top because of the I1. So this is top and this is negative, and its value will be j omega m plus this current I1. Similarly, this one is because of current I2. So where is the current touching the coil first? Non-negative terminal or non-dotted terminal, sorry. So non-dotted terminal, that means the negative terminal will be at the top and value will be j omega and the current I2. Now we'll just mark the polarities depending on the current direction, and we are ready to write the KVL equation. So for the left loop, we go from here, negative V, I1 R1, I1 j omega L1, and negative j omega I2. So this is our equation for the left loop. Rearranging, we get this one. Now we go to the right hand loop, again KVL, starting from one corner, negative j omega m1, negative j omega m1 plus j omega L2 I2, then R2 I2 and ZL I2. So all these simplifying. And now from here we'll take out the value of I2. So from here, rearranging the I2 will be this value. So I2 had found, and we'll put the value of I2 in the first equation. This was the first equation. And so putting the value R1 j omega 1 I1, and this I2 will replace by this value. So we have I1 here also. We'll take I1 common and divide or take it on the left hand side. So it will be V divided by I1, and whatever left is we write on the right hand side. So R1 j omega L1 and this term. Now here this is a negative sign, but here we have written positive. It's because when j multiplied by j is j square is equal to negative 1. So negative 1 multiplied by negative is positive sign. So this is our equation. And we know that V over I is the impedance, so we are here. So V over I1 is the input impedance Zn. Now this is called reflected impedance ZR. So ZR is this value, reflected impedance. Secondary impedance seen from the primary side is called reflected impedance. And the equivalent circuit we can draw like this, R j omega L, and this is the reflected impedance. Now, you don't have to memorize this term. It's a very simple technique. You see the top or the numerator is coupling square. So coupling is j omega m. So we take omega m square divided by the secondary side impedance. So all the impedance on the secondary side are 2j omega L2 and ZL. So that is how we can easily remember this. The location of the dots in this circuit does not affect the result. So this is just for your knowledge. Okay, now in the examples that we'll be solving, instead of R, he has used Z1 and Z2. So simply in the formula, we replace R1 by Z1 and R2 by Z2. Okay, this is the example 13.4. In the circuit, calculate the impedance, input impedance, and current I1. So this is the circuit. So straight away we'll use the formula. Zn was this formula. This, if you remember, coupling square divided by the secondary side, or you might just copy this from the book. So this was the formula. Plugging in now the values. Z1 is this term here. J omega L1 is J20. And omega square m square is 5 square on the top, and divided by this whole term, 30 plus J40, then J40, then 80, J60. Solving this, you get this answer in the rectangular form, and this is in the polar form. So let's see how this was achieved. Your calculator, it should be in the complex mode. The best way that you confirm, you go to mode 2 for complex, so press 2. Now it is in the complex mode. Now we can enter the value directly. So we'll write 60 minus J100. So minus 100, and instead of J we'll write I. So this is I. So we'll plus this sign, engineering. So 100I plus J20, that means plus 20I, plus 20I. Now plus this term. Now this is in fraction form, so we'll use this button, fraction top 25. So 25 at the numerator, and then we come to denominator and we enter all these values. So 30 plus 40I plus 40I again. So 40I plus 80 plus 80 and plus 60I. You could have simplified all it just by adding these, 30 and 80, 110 and 40, 40 and 60, 140. And that way it would have become easier. Anyway, so we have entered all. We move forward and press equal sign. So this is the answer, but this is in fraction form. We press SD. So now you can see it is 60.068, 60.0689, and the other part is 80.11, 80.11 negative with J. So this is in rectangular form. From here directly we can go to polar as well. Shift complex 2. 3 options, we select third option. 3 r theta equal sign. So the value is 100.14 and angle is 53.1. So this is, we have found Z, and now we'll find the current. I is V over Z. This is V divided by this value of Z. So this is current. And now we'll solve the practice problem, exactly same technique. Just write the formula, plug in the values. This is 4, J8, omega square m square, that means 3 square, and enter all these values at the denominator. Solving, this is our Z in, and current I will be V over Z in. V here is 40 angle 0 divided by Z in. So this is the answer for current. I hope you have been able to follow this. Let me know through your comments. Thank you.